Title a new page in your spiral notebook, Writing Polynomial Equations, and we're going to get right into example 1, okay? So what we're going to start with is we're going to write a cubic polynomial, all right? So what degree does that mean that we are writing a polynomial of? So hopefully you're thinking a third degree. So write a cubic polynomial with a vertical stretch of 2, okay, with roots 1 plus or minus 3i and negative 5. So the reason that this is following the factoring concept is because we're basically going to we're starting with the solution, and we're going to write the equation in factored form and go backwards and write the equation. So what we're going to start with is, let's just take a second to kind of understand what was given to us. It says that the vertical stretch is 2. Now what that means is that a equals 2. So we've been used to seeing this a value as being the vertical stretch with parabolas, but really a just stands for the leading coefficient, and the leading coefficient of any function is going to be the vertical stretch. And so then we're given the root x equals 1 plus 3i, the root x equals 1 minus 3i, and the root x equals negative 5. So now what we're going to do is we need to think about how this can be written as a factor, okay? So I'm going to come down here, and we're going to write this in factored form. Okay, so let's just kind of maybe call this f of x, and I'm going to put the 2 out front as the vertical stretch. Now, right here in red, I want to show you my thought process for how to turn x equals 1 plus 3i into a factor, okay? Well, what we need to understand is that if a factor, okay, I'm just going to kind of do this right here. If a factor is x minus 3, then that means that the root equals x equals 3, okay? And if the factor is x plus 5, then that means the root equals x equals negative 5. And so what we need to do is go backwards and take the x equals and go backwards and make it into the parentheses. So we need to think about minusing the 1, and we need to think about minusing the 3i. And so if we get everything on the same side of x, this would look like x minus 1 minus 3i. And that would be the factor. Again, we're going to think about minusing the 1, but here we're going to add the 3i. So the second factor is going to be x minus 1 plus 3i. For this factor, we're going to think about adding the 5 back over, and this is going to make the factor x plus 5. So let's go ahead and write this. This is going to be x minus 1 minus 3i, x minus 1 plus 3i, and then that final factor x plus 5, okay? So now what this turns into is a big multiplication problem. And what I want you to start with, I'm gonna leave the 2 out front. I want you to start by multiplying these, which are conjugates, right? Remember, we talked about this. Conjugates are plus or minus pairs. So what I wanna do is I want you to think about multiplying out these conjugates. Technically, you should be able to multiply it in any order you want, but if you want this problem to go a little bit easier, I want you to come over here and I want you to start by multiplying this out. We're going to take x times x, and we're going to get x squared, okay? And then we're going to multiply, and we're going to get x times negative 1, and this is going to give us negative x. I'm trying to keep this straight with the colors. Okay, and then what we're going to do is we're going to finally take x, and we're going to take x times 3i, and what that's going to give us is it's going to be 3ix, okay? So now what I'm going to do is I'm going to take the negative 1, and I'm going to distribute the negative 1 to the x, and that's going to give negative x, okay? It's going to become negative 1x. And then we're going to take the negative 1, and we're going to distribute the negative 1 to the negative 1, and that's going to cause us to get plus 1. And then we're going to take the negative 1 and distribute it to the 3i. And that's going to cause us to have negative 3i. Okay, so we're almost done. So now what we need to do is let's take the negative 3i and let's multiply the negative 3i by all three terms, okay? So the result's going to be negative 3ix plus 3i minus 9i squared. Don't forget that I squared right there. That's really, really important, okay? Right here, don't forget that squared. And so then I'm going to close this parenthesis and I'm going to bring down the x plus 5. Now let's go ahead and look at this because this looks really complicated right now. Let's go through and see if any of the terms cancel. I don't see any x squared, so we're going to bring down the x squared. All right, I see here that I have a negative x and there's a negative x, and so that's going to combine to make a negative 2x. Okay, the next thing is I want you to see is there's a 3ix and a negative 3ix, so that's going to end up canceling. Okay, so I'm just going to kind of cancel those out right here. And all right, so let's kind of put a line, cancel those out. And then is there anything else that cancels? Let's see, I already combined the x's, I already combined the x squareds. Oh, I also noticed that there's a negative 3i and a positive 3i. The last thing I want you to notice is this right here, the negative 9 squared. This is negative 9 and I squared is negative 1. So this whole part right here is going to turn into a plus 9. Well, if we combine the plus 1 and the plus 9, this is going to be a plus 10. So when you multiply out these factors of like we did, you're going to end up getting a trinomial. So let's go ahead and it's really up to you, okay? I'm going to go ahead and distribute the 2 first. And so we get 2x squared minus 4x plus 20. And then the final thing is let's go ahead and take this and let's now distribute out. And what my plan of attack is, let's take the 2x squared times both the x and the 5. So we'll get 2x cubed plus 10x squared. And then I'm going to think about taking the 4x, the negative 4x, and multiplying it by both terms. And that'll make negative 4x squared minus 20x. And then I'm going to think about taking the 20 and multiplying it by both terms, which will be 20x plus 20 times 5 is 100. And so finally, after all of that math, here is our standard form. It's going to be 2x cubed. This x, 10x squared, and this negative 4x squared is going to combine to make plus 6x squared. I can also see that this negative 20x and positive 20x happen to cancel out, which means then the constant is 100. So really, it's not that new of a concept, and it relies a lot on understanding how to multiply. So if you can get through and multiply this correctly, these really are not too difficult of problems. All right, so here's the last example that we're going to run through. And let's, instead of telling you what the roots are, we're going to look at a picture, okay? Let's say in this that we write the quartic function. Now, what does that mean to be a quartic function? What degree are we talking about? Okay, write the quartic function in factored form. All right, hopefully you were thinking before when I asked that question that this is going to be a 4th degree. Now we're gonna have to take a second to make a picture. And when you go to do this on your homework, there'll be a graph that's already included, but I don't have that luxury right now. So we're gonna do our best we can to sketch a picture. One of the zeros is gonna be -4. It's gonna hit right here at 0, and one of the zeros is gonna be at 3, okay? So the polynomial is gonna come up. It's gonna go up and hit this absolute maximum. It's gonna hit the x-axis and go back up, and then it's gonna come back. Oops, I don't quite like how that went right there. All right, so our polynomial is gonna go up, hit this maximum, come down, hit 0, hit another maximum, and then it's gonna go through 3, okay? So not the best drawing in the world, but I'm doing the best I can here. So our roots are going to be -4. This is supposed to hit right here at x equals 0. x equals 3 is one of the roots. Let me see if I can kind of write this out right here. Okay, so one of the roots is x equals -4, x equals 3, and it hits at 0, and it doesn't cross the x-axis. I understand that my drawing is not the best right there, but you know what I meant to do. It's just going to touch the x-axis and then go back up. Now, the one other thing that we know for this is that it passes through the point -2, 10. Okay, so that's going to be an important point right there. Let's go ahead and let's work on writing this in factored form. So when we start this, I go f of x equals, I'm going to start by putting an a value out front because I don't know what the vertical stretch are. But here's the roots based on what we're given. The roots are x equals -4, x equals 0, and x equals 3. Well, part of the problem is that's only 3 roots, but this is quartic, which means it's x to the 4th power. So let's remember a concept that we talked about, and that is the concept of a multiplicity. Because right here, this root touches the x-axis and doesn't cross it, it has to be a multiplicity, but based on the degree, since the degree is 4, the only multiplicity that would make sense is to be a multiplicity of 2. So if x equals -4 and x equals 0 but counts twice, and then x equals 3, that adds up to a degree of 4. Now, if x equals -4, the factor is going to look like x plus 4. And if x equals 0, then the factor could just be expressed as x. There's really no need to write it as x minus 0 because minusing the 0 doesn't do anything. So we can just write that as x. And if x equals 3, then the factor can be expressed as x minus 3. So let's go ahead and write this in factored form. We have this a value. The first factor is x plus 4. I know that the next factor is going to be x, and because of the multiplicity, I'm going to square it. Okay, that's how I indicate that multiplicity, and the next factor is x minus 3. Now I'm going to take a step and kind of, well, you know what, it's fine. We'll kind of fix that up at the end. Now, to make this graph pass through the point -2, 10, it's the vertical stretch that makes that happen. So what we're going to do is we are going to plug in the point -2, 10. We're going to plug in -2 for x and y for 10 and solve for that a value. And so let's plug in 10 for the y value or the function value. I've got this a, and then I'm going to substitute in -2. You know what, I'm going to go back and write this 10 in red too, because really I plugged that in as well. Okay, so then we get -2 plus 4, and in here I plug in -2 squared, and then the last factor we're going to plug in -2, and it's going to be -3. So let's work first on figuring out what this a value is. All right, this is going to be +2. -2 squared makes -4, and -2 minus 3 makes -5. When I multiply all of this together, it's 8 times -5. It makes -40 times a. Divide both sides by -40, and we get that the a value is -1/4. That is the vertical stretch that will make that polynomial pass through that given point. So let's go back to our factored form, okay? The a value is -1/4. We knew that it was the factor x plus 4. We knew we had an x squared, and we knew we had an x minus 3. The only thing I'm going to do, and maybe we could have done this earlier, is it kind of looks funny for me to have that x squared in the middle. And so a lot of times right here, we can express this as -1/4 x squared, and then write it as x plus 4 and x minus 3. Okay, and then that looks a little bit more normal. So that is factored form. If I were to multiply this entire thing out and distribute and do all of the multiplication, I would get the equation in standard form. But luckily, it just said to write it in factored form. So hopefully this helps. You're going to try the homework from here and come to class with any questions that you have. All right, thanks for joining. Bye.